discussing about second program of ADA laboratory. So in this C program, the problem statement says that we need to design and implement C or C++ program to find minimum cost spanning tree of a given connected undirected graph using the Prim's algorithm. So it is similar to that of first program, but here the type of algorithm we are using is different. So in the first program we have used Kruskal's algorithm. So in the second program we'll be using the Prim's algorithm. So it implements the C program implements Prim's algorithm in order to find the minimum cost spanning tree of a given graph. So, as we know that the purpose of this program is to find the MST, that is minimum cost spanning tree of a connected, undirected and acyclic graph using the Prim's algorithm. So, this algorithm works in such a way that it will grow the minimum cost spanning tree by adding the nearest unvisited node at each step. So this is the goal of the given problem statement. So here the variables we are using is that n. So where n represent number of nodes or the vertices and the cost matrix. So it represent adjacency matrix representing edge cost. So next we have declaration like visited. So it keeps track of which nodes have been already been added to the minimum cost spanning tree so that it will avoid need to call that node again and again. Okay, so this visited of 10, it will keep track of all the nodes which have been already visited and have been already added to the minimum cost spanning tree. So next we have variables a and b, so it stores edge endpoints. So next we have minimum, it stores the current minimum edge cost, so followed by minimum cost, so it will store the total cost of the minimum spanning tree. And we have ne, so where it stores the number of edges included so far in the minimum cost spanning tree. So that is about the declaration, we have made it over here. So as usual, our C program starts with the main function by asking the number of nodes. So here the user need to give number of nodes in order to construct or in order to grow the minimum cost per unit using Prim's algorithm. So this program is basically the user input program where it allows the user in order to give the input by themselves. So where user is allowed to give that desired number of nodes in order to grow the minimum cost spanning tree. Okay. So the next step, so it will come to the next print statement, that is enter the adjacency matrix. So what it will do means it will take input for the adjacency matrix from the user. So in the previous video we have discussed that if there is no any direct edge between the two nodes, it is usually represented by the number 999. So don't get confusion. So 999 indicates that there is no direct edge between the two nodes. Okay, so in this for loop and with the help of the print statement, it will take the adjacency matrix from the user. Okay, so in order to start constructing the minimum cost spanning tree using the Prim's algorithm, so let us start our program from visited of I equals to 1. So what it will do means it will mark node 1 as visited. So in order to construct any spanning trees, we need a particular node, usually the starting node. So we'll consider that in order to construct the minimum cost spanning tree further. So in order to do that, so we'll usually initialize visited of I equals to 1, that is this one. So that is first node is marked as visited, so keeping that as the root node or the starting entry of the graph, will start constructing the graph further. Okay, so next we'll move to the loop in order to build the minimum cost spanning tree. So here we have while ne equals to while NE is less than N. So this condition, from this condition, so it is used to build the minimum cost spanning tree. So the loop will run continuously until the minimum cost spanning tree has N minus 1 edges. Okay, why here N minus 1 edges is that we have already taken first node, that is here we have marked the first node as visited, right? So we are taking n minus 1 edges, so this condition will be running until it meets the criteria n minus 1 edges, that is all nodes are connected, right? So next we have one more for loop. So in this for loop, so what does it mean is that, so it will search for the smallest edge, so which will connect a visited node to a unvisited node. Okay, so that is the use of this for loop. So what happens next is that when the smaller edge is found, it will store its details. So that's why here we are declaring this variable as minimum. So in order to find the smaller edge. So after that, so we'll add the edge, so if this connects to a new node, so we'll add the edge only if it connects to any other new node. Okay, so that will be usually done using this if condition. So, okay, so what does it do means, so it will add an edge. So if there is any possibilities of that node connecting to any other new node, so after that it will ensure the edges is connected to at least one unvisited node. So here we are not taking any visited nodes here because visited nodes are usually not considered. So here we'll always be looking for unvisited nodes. So this if condition, what it will do means, it will ensure the edge which will connect to at least one unvisited node to avoid cycles. So we know that the purpose of this problem statement is to have undirected and acyclic graph. Okay, so we should avoid the cycle formation. Okay, so the next step is that, so we need to print the edge and its cost. Okay, and the new node as visited node. Okay, so that will be done using these statements. So here we are forming, or we are printing the edge and its total cost here with this statement. So we are printing the edge and its cost, and we are making that particular node as visited node. So now it has been changed from unvisited to the visited node. So next we have cost of AB. Okay, equals to cost of B equals to 999. So what does it do means, it will mark the edge as used. Okay, by setting the value 999. Okay, so it's not to avoid this edge not being picked again in the future. Okay, at the end it will print the total cost of the minimum spanning tree. So here, so this is the flow of the program in order to construct the minimum cost spanning tree using the Prim's algorithm. So the sample output will gonna look like this. So here we are entering the number of nodes as 4. Okay, so the algorithm start with node 1. So later it will pick the smallest edge that will connects to any other new node. So this step will be repeating until all the nodes are connected in the given graph. So by avoiding the cycle formation in the graph in order to build the minimum cost spanning tree, or in order to derive the subgraph. So these are the minimum cost we have obtained so far from three edges, edge 1, 2 and 3. Okay, so by adding all this minimum cost we have obtained so far from all the edges, so finally we'll obtain the minimum cost as 6. So this is the flow of the second lab program, and this is the sample output of the same. So hope this is clear. So we'll continue in the next video with the program 3. Thank you.